Session 1, Infrastructure as Code. Session 1, Introduction and Lab Setup. Agenda of the session is Virtualization and Cloud Computing, Introduction to Virtual Networking and NAT, Oracle VirtualBox, SSH and key-based authentication, importing the virtual machines, and setting up the networking between the machines. So by the end of this session, you will understand what we will be requiring and why. Remember that we'll be covering Ansible Kubernetes also. Therefore, we need to set up at least 3 machines. 2 will be character user interface, CLI based machine, no graphical interface, and 1 will be server graphical interface based machine. 2 machines will be very lightweight, around 1 GB. The third machine, the server machine, is comparatively bigger machine, 5.7 GB. Once you import all, 2 machines will be shared with you, server and tester 1. Tester 2, that is machine third, will be clone of tester 1. So you will have 3 machines, server, tester 1, tester 2, which I will show you after the session is over. Virtualization and cloud computing. So these are the agenda. These are the topics which you will understand. Let's start. Virtualization. Virtualization basically represent the concept where multiple operating systems resides on a single machine, giving an illusion that each operating system is running on real hardware. For example, we have this hardware, then we have virtual machine monitor, also known as hypervisor, and we created 3 machines here. One is Windows machine, another Linux machine, and Mac machine, and our applications and binaries and applications are running in isolated environment in independent virtual machines. That is virtualization. This virtual machine monitor, also known as hypervisor, is another layer of kernel to virtualize multiple operating systems, also known as hypervisor. Virtualization and cloud computing. What is the relationship between the two? We can't think of cloud computing without virtualization. In fact, first came virtualization, then we realized the power of virtualization, and that power resulted into the development of cloud computing. How? This slide will explain that concept. Virtualization is ability to run virtual machines on the top of hypervisor. Hypervisor provides a uniform abstraction of the underlying physical machine. Abstraction is the key idea in service models of cloud. Virtualization can make one resource act like many, while cloud computing let different departments through private cloud or companies through public cloud access a single pool of automatically provisioned resources. Let me explain this concept. We use concept of LVM to extend the disk space. Dora will recollect that. Yes, we did it. When we add extra disk and we create a physical volume out of the disk, then we add this physical volume to volume group, and then we can extend logical volume, and thereby we can extend the file system. That gives the scalability. That gives 2 different aspects. One, at one end we keep on adding the disk space, at other end we keep on consuming what we need or provisioning what we need, extending the file system or the disk or the block volume. This is perfect example of how this abstraction concept is used in cloud computing. At one layer, what we have is the virtual resources, pool of virtual resources. We keep on adding the physical resources, then we create abstraction layer, and we create a pool of these virtualized resources on the top of physical resources. And then we allow users to carve out the required resources based on what they pay or what they need. That is on demand. So hypervisor provides the uniform abstraction layer. Hypervisor help you to virtualize that hardware part, to give you virtualization. And this abstraction is the key idea in the service model, because cloud is all about methodology. Cloud is all about offering The resources on demand, virtual resources to be precise, on demand. There are many types of virtualization, but basically we will discuss two here to give you idea that why we are using VMware Workstation or Oracle VirtualBox. Any of them can be used. Why? In our training, because we'll need three machines, we'll be creating Ansible, configuring Ansible, uh, managing machines remotely with Ansible, or managing creating Kubernetes cluster with 3 node cluster. So we'll be needing machines. So which virtualization we will be using in our case, in this particular example, and what kind of virtualization cloud computing works. Though there are virtualization and wine and other concepts here, but our focus is these two, type 1 versus type 2. It depends on what sits right on the hardware. When we say type 1, the hypervisor or the virtual machine monitor sits on the hardware directly. When we say type 2, it is the host operating system which sits on the hardware. That means we talk about the operating system, and then we install virtualization software on the top of the operating system. So in this example, if we see, we have hardware, hypervisor, and we install guest operating system on the top of hypervisor, and we create guest virtual machine. Here also guest operating system, guest virtual machine. But in this case, in type 2, we have hardware and we have host operating system. On this operating system, we install hypervisor, and then we create guest virtual machines on the top of this virtual machine monitor or the hypervisor. Examples of type 1 is ESX, Hyper-V, OVM, KVM. This is what we see in the cloud. Whereas in local environment at our home, what we prefer is this, because we can't give the entire hardware to the virtualization or the virtualization software. So we use VMware Workstation or Oracle VirtualBox. Both these offer the virtualization capabilities, and we use them to create virtual machines in our environment. And that's what we are going to do. We are working on it. So what is the difference between virtualization versus and cloud computing? By definition, virtualization is a technology, whereas cloud is methodology. Purpose of virtualization is create multiple simulated environments from one physical hardware system or pool of hardware, you can say. But cloud is pool and automate virtual resources for on-demand use. The most important part here is for on-demand use. You need them, you provision them. You don't need them, terminate them. Use cases: deliver packaged resources to specific users for specific purpose. For cloud, deliver variable resources to group of users for variety of purposes. Configuration wise, virtualization is image based, whereas cloud is template based. In cloud, we always talk about templates. We have templates and templates and templates, nothing more. So whatever we create, when we create machines, we use templates. We create resources, networking, we use templates. So, or the shape. In Oracle Cloud, we use these terms. Shape is the term used in Oracle Cloud. Cost wise, virtualization has high capital expenditure, low operating expenditure. Here in cloud, private cloud has high capital expenditure, low operating expenditure, and public cloud have low capital expenditure, means initial investment, and high operating expenditure. Scalability: in virtualization, you scale up, means you convert one cat into tiger. You add power to it. In cloud, you scale out. You convert one cat into multiple cats or 100 cats. That's example visualizing that concept. Oracle VirtualBox, that's what I'm going to use for a local demonstration. Oracle VM VirtualBox is cross-platform virtualization software that allows users to extend their existing computer to run multiple operating systems at the same time. Designed by for IT professionals and developers, it runs on Windows, Mac, Linux, Solaris, all operating systems supported. Ideal for testing, developing, demonstrating, and deploying solutions across multiple platforms on one machine. Virtual network switches. This is a simple software construction on a host server that your virtual machine plug in. to and direct the traffic through. On Linux server host, the virtual network switch shows up as a network interface. So virtual network switch on physical machine, this virtual machine is virtual network switch is connected to the physical host, and what kind of arrangement we have this between this network switch and this decide whether this virtual machine can connect to the outside world or not. This communication is allowed or not will be decided by what kind of arrangement we have between these two, the physical host and the virtual host. I mean physical switch and the virtual switch. Virtual machine plugs into this virtual switch only. So we have two kind of switches in our Oracle VirtualBox. One will be used as NAT, that is network address translation. And as I said, arrangement decides here. If you are using NAT, then these machines can reach out to the cloud using the IP address of this host machine. So therefore this IP address will be visible to the outside world. So hence the outside world cannot reach to these machines. That's not possible, because the IP address, this is local IP, and these machines can interact with outside world, but outside world cannot reach. That is network address translation, which is applied between the physical switch and the virtual switch. Any guest connected through it use the host IP address for communication to the outside world. Computers external to the host can't initiate communications to the guest inside when the virtual network switch is operating in NAT mode. What are the uses of NAT mode? It can be used anywhere where there is no need for being seen on the network. For instance, a web developer who optimizes web pages for different operating systems and web browsers is preferred choice is NAT for them. Or any other developer who need to try things out in different configurations, environments, or operating systems. NAT is excellent for that. SSH and connectivity. We are going to create two machines, and the third machine will be created will be created using the clone of tester one. So eventually we'll have three machines. These three machines needs to talk to each other for Ansible and for Kubernetes. For our training, these are the two topics which will be using the three machines. Therefore, we need SSH and connectivity. Particularly for Ansible, it is much more important than SSH stands for Secure Shell. It's a network protocol that allows access to server from client using PuTTY or terminal. When using a command line tool to perform SSH connectivity, it is not encrypted and hence not secure, especially on public network. Network snipers can open the packets using packet analysis like Wireshark and other tools. SSH keys are based on public key cryptography, a cryptographic network protocol used over unsecure network. It provides a secure channel over unsecure or public network. An SSH key is a key pair. That means we create two keys. Public key is sent to the server to be authenticated, and private key is kept at the client, and this is the same thing we will be using in Oracle Cloud Infrastructure also. I'm going to demonstrate this for local as well as OCI. Tools to create SSH key. On Windows we use PuttyGen. On Linux we use SSH-keygen commands. So the configuration commands are, first command is what we use to connect, that is SSH. To make it work with key-based authentication, you need a private key on the client from where you are connecting and public key on the server to which you are connecting. We need to copy the public key like this to authorized keys files under .ssh folder of the remote machine. However, copy is not the right word. SSH keygen is the utility which is used to create key pairs, and SSH keygen -t key type we can use key based on different algorithm. By default, when you use SSH keygen without -t option, then you will be creating RSA key pair. But if you use you want to create ECDSA or other, you can use -t option. This is the command which is actually used to copy the keys, ssh-copy id, and this is what I was talking about. So this is a script that copies public keys to target remote systems. The configuration files. The systems configured with SSH include configuration files in two different directories. For local systems, basic SSH configuration files are stored into etc SSH directory. The configuration files in each user's home directories are also available under .ssh in the home directory of the user. Those files configure how the given user is allowed to connect to remote systems. When RSA keys are created, .ssh subdirectory include these files. First will be authorized keys, but this include a list of public keys from remote system. You remember I told you that you copy public key to remote systems. So this file will be created when we copy public key to the remote machine. So this is on the remote machine. The system users and names are listed at the end of each public key copied to this file. The demo will clarify the same thing because I'm going to demonstrate the same thing. ID underscore RSA include local private key based on RSA algorithm. ID underscore RSA.pub, this include the local public key for the user based on RSA algorithm. Known host contains the public key from remote system, and this by default does not exist. This will be created when a remote machine connect for the first time, because first time when you try to connect to the remote machine, you will be shown a warning. Once you accept that, this file will have the host name added, and in subsequent connections you will not be asked and no warning will be displayed. The first time user log into the system, he is prompted to accept the public key on the remote server. The corresponding public key on the remote server is added to the client to its known host file. This is what I was just talking about in the previous slide. And this is the importing the virtual machine I just showed before this session, and I'm going to demonstrate once again because my tester machine is yet to be imported. So to import the downloaded virtual machines, go to File, Import Appliance, select the machine, then you will be prompted, you will be shown this kind of interface. So and then first step is you click on Import Appliance, then select the file, and then dialog box, select this and then import it. Networking between the machines, we require two adapters. NAT is to connect to the internet, OCI and software updates. Host only adapter for connecting virtual machine with each other. This is requirement for our Ansible and Kubernetes part. To set up host only adapter in Oracle VirtualBox, you go to File, Host Network Manager, that is File, Host Network Manager, and then click on Create and accept the default settings. Inside the virtual machine, this adapter will be shown here as this etc sysconfig network script ifcfg enp0s8, and this is where I have configured the static IP address, fixed IP address. That is the reason my host network manager should have a specific subnet, because IP address is already configured. The machines are already pre-configured with the static IP address using a specific subnet. The first adapter, which is NAT, will be the configuration files are located in this ifcfg enp0s3. So first adapter is NAT, second adapter is host only adapter. This is the screen grab. So 10.10.0.2, this is first time when you select. Before you apply, you will see the different IP address, but you need to apply it. After you apply, you will get the adapter proper configuration. And this is DHCP, means I'm talking about ENP0S3, and ENP0S8, if you see, that have the static IP address, not precisely this in this case, but static IP address, because configuration is static, as you will see here just now. That's all for this session. I will continue the import part of the machines. So let's start this machine. and let's say continue with the import part of the second machine. This is server machine. So import appliance, select the machine, that is second machine. When you download, you will get the second machine also, that is tester 1. So import this machine and click on import. Now as the machine is being imported, if you want to see the settings of the machine, here we have a shared folder option which can be used to directly pull the data from the host machine. Guest machine additions are already installed. Machine settings, if you want to see, you can see the network part I was talking about. Because the machine is started, so this is not enabled, this is disabled. If the machine is off, you will be able to change it. So network, if you see, first adapter is net and second adapter is host only, and I have selected the first adapter from the 3 available adapters in my case, and the first one is having the IP address of 10.10.0.1 series. So that's the reason the static IP address will work perfectly fine with my server machine. As far as the system is concerned, this machine is having one processor and 4 GB RAM. The storage is, there is one disk, network, 2 adapters. That's all about this machine. Once the machine starts, I will talk. How can we add users? I'm going to demonstrate how to create additional user. If you have your partner and you want to create credentials for that user, how to create that user and how can we share the credentials. I'm going to show you that also. So I'm logging in. So for that, we have identity and access, identity and security. And here we have users. I'm going to create one user because I want to allocate the user complete administrative rights. So I will be using that option here. Oracle Identity Service or Identity and Access Management. So recommended is IDCS, and though you can select IAM user also. Username is, let's say, Sangwan. Email is, I'm supplying this email ID. Confirm email ID, first name, last name, mobile number, fill in the details, and group. I want to put this under administrators. So IDCS administrators and also OCI administrators. So this will give you complete power to this user because I want this user to be administrator. So simple username, password, and create. The user is created. Now this user will be able to log in, as simple as that, and this user will have all the rights. If I want to reset the password of this user, I can reset the password. Are you sure you want to reset the user password? Reset it, and you can do that when the user forget the password. For the first time when you user logged in, you can see that user also. So this is how we create the user. That's simple, and you share this user. Hey, you can use this username and this password. You can do edit also. You can edit. I don't want to edit anything. I want to reset the password, and the password is sent. Mail is password set reset instruction has been sent on the mail. So there is nothing, you type the password anytime. All right, now I'm going to log in as RN Sangwan user. So I'm logging out from here. So I'm going to my Gmail, see Oracle, and here use to set your password. So I'm setting the new password here. So I type this password is shared, and now I can log in. Okay, username is Sangwan. Yes, I'm logged in. So this is you don't have any access rights yet, but let me go to OCI and I should be able to log in. Sign into the cloud, Skillpedia, continue. I'm trying to log in again and see I'm logged in. I'm logged in as Sangwan user and I got all the rights. So I'm working as Sangwan user. Now to work as Sangwan user, to launch an instance in the cloud, here we have the options of creating networking resources here. Like first we used to create Vcn initially, and then using that Vcn we used to create the resources, the instances. So let's see what all resources I have. If I have an instance, I'm going to terminate that. and I'm going to, yeah, there's one instance. So let me terminate it. I don't need this instance. This was only for testing purpose. Networking also, I'm going to terminate all the networking resources so that I can start from scratch, because this is just demonstration only. These resources are created, and trust me guys, I don't pay much. I have never paid more than $4 or $5 per month. When during the training I use this, but I never use, spend anything. So terminate this VCN, and this will terminate the resources. So this also I'm terminating. Now I have nothing. Oh, this is being used, so that means the instance is not terminated yet. It will take time, no problem. Compute instances. So this instance is still being terminated. So once it is terminated, I can terminate the VCN also. Now to work with the instance, with the console, you need to be comfortable. If you notice, I'm working at 80% zoom level. The best is 80%. If you make it 100%, it will be too big and you will be scrolling here and there for options. So better is to reduce the zoom level to 80%. That will give you comfortable view of your resources. Now, launching compute instance using OCI. Theoretically, I will discuss that. I'll talk about every option, every feature. But first, I'm going to demonstrate. Entire training will happen in three-phase learning. First phase will be demonstration. Second phase will be discussion. Third phase will be lab assignment, which you will do yourself. So creating a user is quite easy. You just go on users, add that user to admin group or give access rights. You have to go inside the security policies in that case. So now I got nothing. So let's create VCN as an example first. Don't use create VCN selected, because that you'll be struggling initially. I don't recommend to use create VCN. I recommend that you use wizard, because when you use this wizard, it will create public subnet, private subnet, internet gateway, net gateway, service gateway. All these things will be created. So this is best choice. Let's understand what these are. When we say VCN, I'll explain that in presentation, but here you can just take a look. The VCN is basically complete network which consists of 256 subnets, and each subnet can have 255 machines inside it. So that means the size of the VCN can have up to 65,535 computers in the VCN. So when we say internet gateway, any machine created in any subnet of this machine will be able to access internet. When we say net gateway, it will be one-way connectivity. Look at carefully this arrow I'm talking about. In net it is one-sided. In IG, internet gateway, it is two-sided. And service gateway to access other cloud resources. So we are going to create this so that we have internet gateway, we have net gateway, and we should be able to connect to the internet, and internet should be able to reach to our machine. So I'm going to create this VCN name. I'm creating this TSP initial VCN1, or let me give a name as TSP, just a meaningful name, in root compartment, and this is a CIDR block, and it's quite simple, nothing more. Create. You see only the compartment and the name I entered. Rest it is done. Now VCN is created. What is created with this VCN is one CIDR block, two root tables, internet gateway, dynamic routing gateway not created. A security list is very important for us. Let's go to this default security list. This you will understand in the lecture, because this demo is to give you idea of the screens and the screenshots. So let's edit the security list. This is the security list. These are the rules of the security list which allow connectivity of the instance. What all ports are open, the instance which is created in the subnet. So let's add one ingress rule here. It is stateless or stateful. So by default it is stateful. 0.0.0.0/0 means the internet. By default the ICMP is disabled, but I'm enabling it. I'm saying from internet ping command should be allowed. in the subnet. The subnet means any instance created within this subnet will be able to pinged from internet. Similarly, I'm opening another port 0.0.0.0/0 and TCP protocol 80 port number. I'm opening source cider from internet TCP protocol port number 80. I'm opening. Why? Because I'm going to configure a website and I want that website to be reachable from internet, because I want to show you, look, you open this IP address and you can access the website directly. So these rules are examples for you to understand how the rules are created in security lists. Let's go and launch one instance now. Compute, instances, create one instance. So give it name, TSP inst1, root compartment, availability domain. You can select any availability domain, which is actually nothing but physical data center. The image which will be used, you go to change image. We have options, Oracle images, partner images, custom images. I will explain each one of during the presentation, but right now I'm selecting only platform, means operating system, and default is good for me. So default image selection is fantastic. Shape, I was talking about the template. Shape gives you CPU, memory, network bandwidth, total. That means you decide what shape you want. And these are categories, shape series. So if you want Ampere, this is allowed. If you are Intel, you have these shapes available. I'll explain even the meaning of these 2.4. What does it mean? 2.2, what does it mean? I'm going to explain each one of them in detail, so no worry. Especially in previous generation, what we have, this E stands for what? You will see that in theoretical lecture. So I'm selecting this Intel based. In fact, default I'm selecting, for me default shape is good, which is always free. So I never pay anything with this shape. Networking, uh, since I already created the VCN, therefore I am selecting this radio button. However, in recent changes, Oracle has allowed to create the VCN directly at the launch of instance type also. So create new VCN right here. So because I already created it before this, I'm selecting this option. Private subnet, assign public IP, all seems good for me. Now the important point is this public key. I don't have public key. Now I'll head it to my server machine. So I'm SSH hyphen keygen is creating the key pair. Default settings are good. Now cat dot ssh id underscore rsa dot pub. This is the public key. So I need to paste this public key in the instance, and the result will be, as you can imagine, what you will be able to connect to this instance from the local machine, because this key will go to that file authorized key which I discussed in the previous session, and create the instance. Once the instance is launched, it will take a couple of minutes, maybe 1 minute or 2 minutes. By the time instance is ready, you will see the public IP address, private IP address, and you can start the public IP. See, the public IP address is given. So copy, start ping command, and the moment you start getting the ping reply, that means the instance is ready. And why we will get the reply? Don't forget that we open the public subnet. We open the ping command by using this IMP, ICMP protocol from everywhere. Otherwise, we would not have been able to ping this. We would have been able to connect, but not ping. So because of this ICMP rule, ingress rule we configured, we will be able to ping once the instance is ready. So let's go back to the instance, compute, instances, and the instance is being created, provisioned. What I have provisioned through console, you will be provisioning through the code. You will be provisioning through Ansible. You will be provisioning through OCI CLI. You will be provisioning through Terraform. This is all training is all about. So session 2, working with OCI console. Virtual Cloud Network VCN. Creating a VCN using Start VCN Wizard. Gateways. Virtual machine versus dedicated compute for virtual machine. shapes and hardware, storage, dense IO and standard IO, creating an instance. Now you will connect. Why? Because whatever topics I am reading, they are not theory. You have seen everything in action. That is the reason I always try to demonstrate first, then explain so that you have the connectivity with the topic. Private and public IPs. Virtual cloud network, which we created. A virtual cloud network that you set up in the cloud data centers with firewall rules and specific type of communication gateways that you can choose to use. A VCN covers a single contiguous IPv4 CIDR block of your choice. A VCN resides within a single region, closely resembles a typical network setup with subnets, gateways, firewall rules, DHCP options, and route tables. IP address range for your VCN. When you create a VCN, avoid the IP ranges that overlap with other on-premise or other cloud networks because that will create conflict and you yourself will be confused because Oracle will not prohibit you. It will allow you to create, but then because it use the OCID of the resources, not the names. So it will be your choice. It is recommended that don't use the IP range that overlap with other on-premise or other cloud networks. Use private IP addresses which are specified in RFC 1918. RFC 1918 refer to the private IP addresses for local infrastructure or for local companies, which cannot be public IPs, which is given in this range 10.0.0.0/8, 172.16.12, then 192.168/12. These are the IP ranges. Allowable VCN size range from /16 to /30. VCN reserve first two IP addresses and the last one in each subnet CIDR block. A VCN is created in a region, that is physical location, and in a compartment, that is logical location in the OCI. 10.0.0.0/16. When you create this is the recommended RFC 1918 range, and this gives you size /16, which gives you 65,526 IP addresses. This is what I have demonstrated. VCN creation, start VCN wizard. You log into the cloud, select VCN, start VCN wizard. This will be demonstrated. That was the purpose of the demo, so that you recollect that, oh, I saw this, how it came. And I recollect that, yes, Ram explained the same concept. So this is same thing. VCN with internet connectivity. However, there were two options here. One was VCN with internet connectivity. There was second option also. That option is discussed here. The first is VCN with internet connectivity. It creates a VCN with public subnet, private subnet, internet gateway, NAT gateway, and service gateway. For new users who need not bother of gateways, route table, security list, can get started with other resources very easily, and that's what we choose this only. Second was VCN with VPN connect and internet connectivity. It creates a VCN with public subnet, dynamic routing gateway, customer premise equipment, IP secure VPN connection, and internet gateway. For customers who need to connect to on-premise network, this is recommended. VCN components are subnet, virtual network interface cards, route tables, security list, DHCP options, private IP and public IP, network security groups, dynamic routing gateways, NAT gateways, internet gateways, service gateways, local peering VCNs, and a remote peering of VCNs. Subnet. We created one subnet, we created one VCN without explaining the concept of subnet in detail. Let's understand that now. Subnets are means to divide a VCN into divisions. For example, this is one VCN 10.0.0.0/16. So this 2 octet will remain fixed. This can change from 0 to 255. So let's say this is value is 1. So this will become subnet 1. This value is 2. This becomes subnet 2. This value is 3. This becomes subnet 3. So we can have so far, if we continue like this, we will have 256 subnets from 0 to 255. And then this subnet 1, this IP will change here from 0 to 255. So each subnet can have 256 IP addresses. So 256 multiplied by 256, that gives you 65,536 IP addresses, as I calculated and I gave you right in advance. Each subnet has a unique IP range within the given VCN CIDR block. VCN subnet types. Availability domain specific subnet provide private IP failover within subnet or availability domain only. Whereas regional subnets provide the ability for private IP failover within the region. Therefore, regional subnets are preferred. This is your Oracle Cloud Infrastructure whole and divided into regions. You always subscribe to a given region. You select a default region also, and every region has availability domains. Now you create VCN which covers the entire region because VCN is always regional. Now within this VCN, you can create subnet which is specific to availability domain, like this VCN, this subnet is in AD1, this subnet is in AD2, and this is in AD3. You can have another subnet which covers all the availability domains, means the subnet is covering the entire region. That's also possible. So which one is preferred? If you have a AD specific subnets, then IP failover is not possible. This is not allowed. Whereas if you are using regional subnet, IP failover is possible. Therefore, regional subnets are preferred choice. VNIC. Every compute instance has at least one virtual network interface card. A VNIC is a virtual network interface card created on the physical NIC of the hardware. So physical host have physical card, virtual machine have virtual card. So this virtual card plug into the physical, and that's how the networking packets pass through. VCN default components are default route table, default security list, default set of DHCP options. You cannot delete these, but you can always modify them. You can add, create additional such components if you want, like you can create route table, security list, DHCP options if you want. These are created at the VCN level, remember. You can associate these to subnet based on your requirement. Route targets, NAT. I explained that in the previous lecture also. First lecture also I explained the concept of NAT. The meaning is same here, though no change. It is a means to provide Oracle Cloud instances, compute instances, access to internet, but one way. Assume this, we are working in Oracle Cloud Infrastructure. In the entire region, we have 3 availability domains, and we have VCN1, which is attached to NAT gateway. Now, this NAT gateway, if we have any instance created in any of the availability domain, that instance will be able to reach out to the internet, and this is one-way connectivity. So traffic can pass in one direction. If you see the arrows, they are single directional, one directional. Whereas if you create a root target internet, that is internet gateway, then it means of providing access to application hosted in Oracle Cloud Infrastructure to clients on the internet. In our case, we created internet gateway as well. It also provides internet access to compute instances, that is NAT gateway function. You can create an internet gateway in a VCN and specify the root rule for the root table. And this is example of internet gateway Similar concept, only difference here is we are creating internet gateway, and if we have internet, then it is two-sided arrow, means traffic can go from the VCN to the internet and from internet to the VCN, thereby the instance inside the VCN. That is example of internet root target. Security list, that was the purpose of demonstration. These terms should not appear new to you because you have seen what security lists are, because we created root rule in the security list. Actually, it is a means to control network traffic in the VCN. Security list is a set of firewall rules. Security lists act as a network level of every VNIC. Therefore, they apply to all instances VNICs in the VCN subnet it is associated with. So means if I create a security list, it will be attached to the subnet, and hence all the instances, or in other words the VNICs, this rule whatever we specify in the security list, they will apply to all the instances or all the VNICs of that subnet. Similarly, we security list 2 will apply to all the VNICs or the subnet or the instances of subnet 2. And we create security list. This was the purpose of demonstration. You recollect that because I showed you the same thing, security list. I clicked on that and I created added rules also in my security list. If you recollect, I use this default security list screenshot. Security list are created at the VCN level in compartments. It's made up of two kind of rule. If you noticed, I added ingress rule. They consist of two rules: ingress, that is allowing incoming traffic, and egress, to allow outgoing traffic from the subnet. Each security list can have multiple rules. If you recollect now, that was the purpose of demonstration. I added two rules. What were rules? That is not important, but I added two rules here. Each subnet can have one or more security list associated with it. And this was the rule where I added one rule, if you recollect. So ingress rule default, it was displayed. I clicked on this add ingress rule and I added ICMP and port number 80 from the internet. And similarly, we have egress rules as well. There was one checkbox, very small checkbox, if you recollect, and I said this is stateful versus stateless. Let's understand the meaning of these two, stateful versus stateless. A stateful rule uses connection tracking, meaning incoming traffic is matched with ingress rule. The response is tracked and automatically allowed or granted. So therefore, we don't no need to create a matching egress rule. Take an example. I open port number 80 and I created stateful rule. So host in the cloud in the VCN is allowing the incoming traffic on port number 80 from any host or from the VCN or outside. If it is stateful, the outgoing traffic will be automatically allowed. That is what the stateful is. Reverse is also true with stateful egress rule. A stateful ingress rule use connection tracking, assuming an ingress rule is available at VCN security list to allow port number 80 as destination, and this was the example I'm just explaining. However, a stateless rule does not use connection tracking. Every stateless ingress rule, there should be a matching stateless egress rule. Compute instances, we created one instance which is about to be ready. I hope that might be ready by now. So immediately after the session is over, I'll continue with the demonstration of the instance. Bare metal, dedicated physical hardware, very costly. Don't try for testing environment, but think of it as physical machines will be given to you. In fact, they may not allow you to create bare metal instance. You may have to raise a service request, and once you raise a service request, they may revert back within 2 days or within 24 to 48 hours to grant you permission to create bare metal instances. Best performance, you can virtualize with KVM, OVM, or Hyper-V. The server is dedicated to the customer, means a physical machine is given to you in the cloud. Virtual machine, independent environment. run as VM on bare metal, same hardware as bare metal. And virtualization, by default, they isolated, virtualized isolation. So we select this instance type, virtual machine or bare metal, what kind of instance we are creating. Virtual machine versus dedicated host. Shared host versus dedicated host, that should be the title of the slide. When we say shared host or shared infra, resources from servers provided to a VM of a customer. Multiple VMs of different customers can be co-located on the physical server. Dedicated virtual machine host, a bare metal server provided to a tenant or customer, where only your as a customer machines can be co-located on the dedicated physical host. Means dedicated physical host is given to you to use virtual machines. Shapes, now you recollect that screenshot. Shapes specify the number of CPUs, memory and other resources allocated to the instance. It's available to bare metal and virtual machine types. Availability of shape in a region is specific within service limits. And image, of course. Standard shape for general purpose workload, only block storage offers. Dense IO shape for high performance, also has local storage or NVMe storage. HPC for high performance computing workloads. So different type of shapes we have. And we select the shape as the launch of the instance. If you recollect, yes, we selected the shape using change shape option. And this was the screen grab of the shapes. So you select machine type, then shape series, and then the shape names and the details. So you select appropriate shape series and you will get all the shapes available. I told you that I'll explain the concept of this ending with. If you see 1.x, 1.2, 1.4, 1 means it is based on X5 hardware. If you see 2.x like 2.2, 2.4, if you see 2, that means it's based on X7 hardware. If it is B.x, then it's based on X6 hardware. And if you see E, that was also visible there, that is based on AMD hardware. The shape names convey the messages, convey the meaning clearly here. Image types, that also I showed you a drop down option where Oracle provided platform images and I selected this only, just operating system. There were other options like Oracle provided solution images used for deploying Oracle solutions. And then we have Oracle partner images in the form of marketplace to run partner specific software on Oracle Cloud. Customers can bring in their own images as well. You can also use boot volumes already created to launch existing machines. How to create a compute instance. Now you will see the demo running through slides. Physically, a compute instance is created in a region, a specific availability domain, a fault domain, and in a subnet of a VCN available in that AD. Logically, the compute instance is created in a compartment. And this was the sequence of steps I used. Compute instances. First step is, in fact, you select the region. If you have subscription to multiple region, you select the right region first. Then root compartment, and then you specify the instance details. Like this is the precisely name I give. You may wonder, I get the same name and same name is appearing because I took the screenshot and I use the same thing. So then you select the availability domain, then shape and image. So you give the VCN subnet details and I give the same details. If you recollect, exactly the same name was given to my subnet also in the demonstration, and then click on create. Now connecting to Linux instance, the one which we created, we are pending this step. I'm going to demonstrate this also. If you created an instance in a VCN with the default options, then there's an ingress security rule in the default security list to allow port number 22. So port 22 is always available by default, but not any other port, not even ping command. For Linux instance, you need to use your private SSH key in PuTTY or Linux desktop for SSH connection. The default user is OPC. So what we are going to do now, we are going to use SSH OPC at the rate public IP address of the machine, because this is required if you want to provide a specific key. Because they're going to use default key, so you don't need even this option -I. Private and public IPs. Every compute instance get a private IP address from the VC insider block. It is optional to assign public IP to the instance. Public IP addresses are available only to compute instance in public subnets of VCN. So public IP is required when the compute instance is to be accessed over the internet. Public IP addresses are auto-assigned to a NAT gateway or public load balancer. The public IP addresses are assigned from the pool available in the OCI. Actually, they are assigned to the private IP object. So, if you want to access any instance from the internet, first requirement is instance should be into public subnet. Second is instance is assigned a public IP. Third, instance should be in a VCN with internet gateway. And fourth, instance subnet should have a root table and security list configured appropriately to allow the incoming connection on the given port. Public IP types, there are two types. One is ephemeral, second is reserved. Ephemeral is by default assigned. They are available till the lifetime of the instance. If you terminate the instance, IP address will be released. Whereas reserved, you create separately. You go to networking, select uh, IP address, where's that IP address? Reserve IP. You select reserve IP and create IP address. So menu networking reserve IPs. So let's understand the difference. Ephemeral IP allowed assignment to the primary private IP of the compute instance, 1 per VNIC and 2 per VM and 16 for the bare metal. In reserved, to primary or secondary private IP, you can assign them, and 32 can be assigned to per VNIC. Creation, they are created during instance creation or later on. Reserved, created anytime and assigned to any compute. Unassignment can be unassigned anytime, resulting into deletion, stopping the compute instance and retain the public IP however. Can unassign anytime and is available with the tenant. Lifetime is tied to the lifetime of the private IP. Here you need to manually delete them. Scope is availability domain, but here reserved IP is regional. That's the difference between ephemeral and reserved IPs. That's all for this session. Let's continue. We are getting the reply or not? Wow, we are getting the reply. So we can connect to this now. SSH OPC at public IP, and it will not ask me as password. I will be directly connected to the instance, and I'm working on the instance now. Now I'm working on the instance in the cloud. Let's switch to root user, sudo su hyphen yum install httpd get wget, just installing some software for the demonstration purpose. And then I'm going to launch a website and I'm going to access that website from internet. And I'll show you, even you can try with that IP address and you will be able to see the website. It should be quite fast. This is the demonstration how to access instance in the Oracle Cloud instance manually. One demonstration. So systemctl start httpd enable, and then of course check the status. Wow, it is running. Open the firewall port 80. Firewall -cmd permanent add port equal to 80/TCP. If I don't open this, that is interesting thing. What will happen? Before pressing enter key, let's show you what will happen. SSH OPC, and let's try the IP address first. So this is the public IP. Though my DHCP server is sorry, HTTPD server, Apache server is already running, but I'm not able to access using the public IP of the instance. And I'm connecting to the instance and I'm verifying that yes, and I'm also creating one page here, sudo su hyphen cd slash var slash www slash html, and here you create your default page vi index.html, h1 tag, hello team, welcome to OCI IAC training, h1 tag closed. This is the default HTML page and I want to see this page. Now point is I am not able to open this because firewall port is open, but instance it's also have its own security. That is the reason I need to open port number 80 from within the instance as well, and I need to reload the firewall. And now I'm sure if I refresh I will be able to access the page. Yeah, see, hello team, welcome to OCI IAC training. So even you can try with this IP address. So what we have successfully done is we have launched one instance using console. We installed some software on the instance and we access that from our local machine. Let's verify the working of tester machine as well. So this is tester one machine. Server machine is already running. Let's configure SSH and key based authentication for local setup. I'm talking about server and tester. So I'm working on the server machine. The IP address for both the machine is configured, static IP address. That you can verify etc sysconfig network hyphen scripts ifcfg hyphen enp0s8, and you see the static IP address I was referring to 10.10.0.100. Also etc hosts has a specific entry for local resolving. So 10.10.0.100 is nothing but server or server.example.com. 10.10.0.101 is nothing but tester1. So I can directly ping tester1 from here because the same file exists on tester1 as well. Let me show you. Root, sorry, root. Now let me show you cat etc hosts and IP space A will give you IP address. So we already have this 10.10.0.100, so I can ping using tester1 from here and server from here. So both machines are connectable. So ping tester1 should work. Yes, it is working. Now I pass on the same key to my tester1 as well. SSH tester1, yes, password is Oracle, and now I can connect to tester1 without password. SSH tester1, and that's what the first time it is. 1 second. Oh, sorry, I have not copied the SSH key pair. SSH hyphen copy ID tester1. What am I doing? 1 second. I'm working on server SSH hyphen copy ID tester1 Oracle, and now I can exit from here and I can directly connect to tester1 and no password will be asked. SSH tester1 and I'm connected. So this is key based authentication. That's all for this demonstration.